And welcome back to 19-4, where we're going to complete our section on neutralization reactions. So far we've introduced you to the equation that allows us to calculate unknown concentrations of acids or bases given the amount of each required for neutralization. We've also talked about a technique called titrations that you'll be using in the lab where you can determine unknown concentrations, and we've shown you two different variations of that. One in which you use an indicator and you stop the amount of base added on your own, or using a pH probe where you titrate through the endpoint and then look back at a graph to determine how much base or acid was needed to reach a neutralization point. In this last podcast, we're going to take a look at two questions that are a little more advanced, where you have multiple hydroxides or multiple hydrogens in the acid or the base. All right. So here we go. Example number 5 says, if 20 mils of 0.5 molar calcium hydroxide is needed to neutralize 20 mils of hydrochloric acid, what is the concentration of the HCl? All right, so again, use your equation MHVH plus equals MOH VOH minus. And now just plug in. Do we know the concentration of the acid? No, that's what we're solving for. So we don't know MH plus. Do we know the volume of the acid added? Yeah, it's 20 milliliters. Okay. Do we know the concentration of the hydroxide? Well, the calcium hydroxide is 0.5 molar, but you get 2 hydroxides for every 1 calcium hydroxide. So you need to double it. Another way to look at that is that if you have 0.50 moles per liter of calcium hydroxide, there are 2 moles of OH minus for every 1 mole of calcium hydroxide. And so in fact you do need to double that. So we're going to say that this is 1.0 molar hydroxide. And then the amount of base needed to neutralize it is 20 milliliters. And so therefore when you divide the 20 across to the other side, MH plus will equal 1.0 molar times 20 mils divided by 20 mils. The milliliters divide out, and you're just left with 1.0 moles per liter, or molar, it'd be the same thing, H plus. And because the hydrogen and the hydrogen chloride is a 1-to-1, 1 mole of HCl for every 1 mole of H plus, the moles of H plus divide out, you have 1.0 molar HCl. Alright. Number 6. If 40 mils of 0.35 molar barium hydroxide is needed to reach into the equivalence point with 50 mils of phosphoric acid, calculate the concentration of the phosphoric acid. Alrighty. Now, again, MH plus VH plus equals MOH VOH minus. Concentration of the acid, unknown. We typically try to find unknown acid concentrations. I don't know why. It's just, at least in the high school, that's what we typically do. But you can solve for any of these. And so now the volume of the acid is going to be the 50 milliliters. Now the concentration of the hydroxide, again you have 0.35 molar barium hydroxide, but you need to double it because you have a 2. You have 2 hydroxides for every barium hydroxide, so we're going to call this 0.70 molar hydroxides. And then the volume of the hydroxide added is 40 milliliters. And now we solve. Divide both sides by the 50 milliliters. The milliliters divide out. You're left with molar. MH plus then will equal 0.7 times 40 divided by 50, which should be 0.56 moles per liter of hydrogen. Now you got to go back and look. This is moles of hydrogen. We want to know the phosphoric acid. There are 3 hydrogens for every 1 phosphoric acid. So 1 mole of H3PO4 contains 3 moles of hydrogen. Divide out the moles of hydrogen, and you're going to need to take that 0.56 divided by 3, and that will give us 0.187 molar H3PO4. A little more advanced, but definitely something you can do using your unit conversions. That concludes 19-4.